Current topic, uh, some environmental friendly technologies and socioeconomic impact. So this is kind of a non-technical topics related to nanotechnology. So we are going to see some of the global challenges and how nanotechnology can influence or can find solutions for those global challenges. So things that we are going to discuss are, first one is one of the most important and the serious crisis globally is the clean water and waste management. Sensor technologies, various different types of sensors for environmental protection, friendly energy that is not harmful for human health or ecology, waste-free industry process, nanotechnology for life-saving medicine, and ultimate green fantasy. So in terms of socioeconomic impact, whenever you are talking about changing anything, finding new solutions, there are lots of legal business solutions, issues that will arise. For example, right now, apart from the geopolitical issue, the US-Ukraine war, apart from the political issue or military issue, one of the important discussion that came is the control on the critical material resources under the soil of Ukraine, right? Why? Why it has become all of a sudden such a hot button issue? Because I'm bringing a completely different perspective. We, as the modern human being, we have become completely dependent on many different types of electronic gadgets. And those requires about 60-something different types of material. If you look at the periodic table, 105 basic material. Out of that 105 basic material, electronic industry uses about 64 to 65 different types of material. And out of those 64 or 65 different materials, less than 1/3 are widely available, like silicon, iron, copper, aluminum, right? And remaining 1/3, next 1/3, they are not rare, but they are expensive, like gold, silver. And last 1/3, they are classified as rare earth material because they are very limited in supply. Only few places across the globe has that minerals or mine source for those material. One of them is Africa. So overwhelming majority of the rare earth mines in Africa are now owned and operated by Chinese government, because Western companies and Western government did not pay attention in late 90s when microelectronics boom started, and they couldn't foresee. They were happy that, well, we have all the technology, all the pattern in our hands, so we can rule this new semiconductor sector, because all the invention came out from this country, mostly America, and a sizable portion from Canada and Western Europe. So it's mainly America is still the holder of the most semiconductor technologies and patents. So they thought that we own the technology, we have the patents, so we can rule. But then the base material, and they didn't think about where they just thought that we will just buy it from open market. But now it has become kind of an existential issue for some of the countries. Who controls those rare earth material, right? So now these poor Ukrainians, they are suffering, and this has nothing to do with, if you look at the news headline, depending on which political angle you are doing, like, people will come up with various different explanations for why this war is happening. But beneath all those political reasons, there is a much bigger truth, that is the control of those rare earth material. And we are in a field which affects us directly, not only our career, also the existence of this whole semiconductor industry depends on easy access to those rare earth material. So there are lots of business issues, like for example, right now, there is a turmoil going on in the stock market. So everything is kind of interconnected. Also, when you propose any new technology-based solution, social acceptance is a very big deal. We have to talk about it, ethical and cultural issue, sustainability issue, as we just mentioned, geopolitical issue. So these are all related. So in this lecture, basically we have to be very careful so that we don't bring any political discussion, but we will try to basically discuss the implication, the socioeconomic implication. So what are the current major concerns we are all worried about? Global warming, ozone layer destruction, sea level increase, extreme environmental pattern, and destruction of natural habitat. Even if nothing happening here, let's say none of these factors are relevant or not severe, but every single day when Greater Kansas City area is expanding, new residential area, new commercial area is being built at the cost of what? Cornfield, forest, lakes, and natural lands. So we are destroying the natural habitat because of our growth, our modern lifestyle, and in the process we are destroying some of our pristine clean water crisis. So now again, let's go back to our subcontinent, the subcontinent I came from. So when British colony left, when they draw the map of India, Pakistan, and now Bangladesh, many people at that time thought that the lines were based on religion. But underneath, those who were making those maps, they used religion as an excuse, but it was mainly the control of some of the most valuable rivers in that region. Because there are mainly 3 rivers that produces all the crops for nearly 2 billion people. So control of the source and the main tributaries of those rivers were actually the main deciding factor who gets what portion. So those were basically, so whoever could influence those colonial master in one way or the other. So that's basically what happened. Like if you look at the map between India and Bangladesh, there is no straight line more than 200 meter long. It's like a zigzag, zigzag, zigzag. Why is that? So popular joke is, the guy who was drawing the map, he was drunk at that time. And he was actually famous. He was one of the British colonial officer, Robert Radcliffe. He was known to be a serious alcoholic. So he was given the charge of drawing the map. So that's why it was like zigzag, zigzag like this. So there is no line more than 200 meter straight. So it's that kind of. So now, but again, still that problem is going on for last 80 years under the cover of religion. It's mainly the control of the most pristine source of water that is coming out of Mount Himalayas. Now, there is a bigger problem arising because up on the other side of the mountain, China, now they are putting much bigger dam that will even prevent some of the biggest rivers coming into India. Now, so this, now let's come back to United States. One of the biggest source of water, clean water, for 9 western states, including California, Arizona, New Mexico, Colorado, is called Colorado River. Colorado River is coming from up north, and on its way, it is delivering water from Utah to Nevada to California, New Mexico, Arizona, all the way down to the western part of Texas. So now there has been several federal lawsuits. Nevada suing against California, California suing against Nevada, Arizona complaining about California. Why? That you are drawing more water than your fair share. So as a consequence, Colorado River is drying up in many places. So some decades from now, if that river dries, Hoover Dam will become obsolete. The biggest source of sweet water in Arizona is called Lake Powell. Lake Powell is fed by Colorado River. So this is actually, so one historian predicted that World War III will be on control of critical materials and water resources. And you can see some sign with what is going on in Ukraine, right? Because 3 parties are trying to get control on these critical material resources. And if they cannot control it properly, there is every sign that the war can get much bigger. Why? Because every country's economic survival, particularly developed countries' economic survival, depends on access to those critical material. But we are the scientists and educators, we always have to hope that we have to find solutions that would be useful for anyone across the globe, across the country, irrespective of their political or other social ideology or identity. So educators have a much bigger, scientists has a much bigger responsibility. It's like you know how to make a very sharp knife, right? You invented a very sharp knife technology. You use that technology to produce knife to do everyday household work, kitchen work, to cut vegetables, meats and fishes, to cook, to survive, right? And then same knife technology can be used to make surgical knife to save your life, put in the hands of the surgeon, right? And same knife, if put in the wrong hand, can kill you. If it goes to a criminal's hand, he or she can use that knife to kill you, right? So we are kind of the inventor of that knife technology, right? We don't know who are going to use it for what purpose. So now research, that's why fundamental science research and engineering research, they're merging to come up with, to utilize technologies and principles at nanoscale to find new solutions to these global challenges. So, but let us now quickly define again what is nanotechnology. What do you mean by nanotechnology? Nanotechnology is the ability to control material at nanoscale dimension. If you can control matter or atoms or molecules of nanometer size, control their physical material and other properties and control them to give them certain forms, certain shapes, certain properties to achieve some application. That is nanotechnology. So typically atoms and molecules, those are nanostructures of nanometer or sub-nanometer size. So if you can achieve atom level or molecular level control, then we have a nanotechnology. So now let's talk about some of the prospective, yes.
So quantum is also considered as nanotechnology?
You can say that yes, but yeah, nano is all about size. Quantum is it's a platform, like you have electronic, you have optical, similarly you have quantum. And nano can be applicable at all these different tracks. So you can have electronic nanotechnology, you can have optical nanotechnology, right? Similarly, a quantum nanotechnology. If those quantum devices can be designed at nanoscale, then it's a nanotechnology. So as we were talking about the water crisis, so these are some of the areas in the world where some sort of across-border geopolitical tensions or war, formal war or informal tension going on for water sharing, for common river or any other. So why this is so important? Because particularly here and some part of China, millions of people, they are experiencing malnutrition and waterborne diseases and infection because of their inability to access usable clean water. Just if you go to Central or North India, there are places where kids and women, they walk 30 to 40 miles every morning just to collect usable water. Same thing in some part of Africa, particularly Sahara. They have to walk miles and miles every day to get clean water. Because of the lack of access to the clean water, waterborne diseases has become epidemic in some places, and it is killing thousands of people. So now what we can do? Now let us give some example. We can come up with easy to use, inexpensive, disposable, widely available filters or some sort of cleaning mechanism to clean those water so that we can utilize any water and make it like drinkable and usable. So one of the example project is Rice University project. Everything I said just to create a background. The Rice University project, they came up with this specific project, some nanoparticle based membrane, and the pores are of the size of nanometer. The whole idea is to use this as a filter medium to separate the pollutant out of water flow. So it's basically a sustainable membrane with nanometer sized pores with particles that will interact with the pollutant atom mixed in the water and separate it from the water stream. So this is, they also used it for waste management as well as for clean water. So this is basically some sort of electron microscope figure what type of particle or nanoparticle they used, and they used a specific nanomaterial called ferroxene to be used as a film form as a filter, and they have macropores, and those pores will basically stop those pollutants by interacting with this ferroxene nanomaterial. So This ferroxide nanomaterial, and in their experiment, they found out that yes, they can be deposited on filters in membrane form. And they found that they have good structural stability and property they need. So this is just one example project. This is kind of a sample from another group, Los Alamos National Laboratory. So they actually are using some sort of nanoporous polymer to absorb different type of pollutant from water. So one of the example is organic nanoporous polymer with pore size of 0.7 to 1.2 nanometer. Basically, they have some very positive material and physical structure, and this particle have the ability to separate organic contaminants of very, very small, minuscule amount of quantity and size from water. So these are different samples and color, which one, like this one for one type of pollutant, this one for one type of pollutant, this one for another type of pollutant. And basically this is a change of the color based on what it is absorbing. This is another example project from UC Davis, University of California, Davis.
Currently, I heard a term PFAS, PFAS, for water cleaning or something.
I have to find out. I don't know exactly what is the chemical composition of that. So when I was in elementary school, at that time, World Health Organization had a project. In rural areas, they used to distribute, rural areas all over the world, they used to distribute small bottle with, you have those chocolates in the form of tablet, like round chocolates, it's like bird's egg. So those are basically, they used to distribute rural areas, and they used to encourage kids, before you drink your water, put one of those into the water. It's basically, it used to absorb, and don't eat that, throw it out. It is basically an absorbent of pollutant out of that water. So it's kind of a way to promote clean water drinking. So you can have many different types of, have you heard about this, I don't know what is the chemical composition, fitkiri?
Yes.
So, in some rural area, they get a tie, it's a crystal. They tie on the roof or on a thread, and then when they have a bucket of water, they actually put the fitkiri into the water for 3-5 minutes and take it away. So all the basically waste, it settles in the bottom of the bucket, and they use a filter or a clean cloth to actually filter out the dirt. So
during the flood in Bangladesh, people used to use the fitkiri for cleaning the water.
Yeah. So there is a very rudimentary way to at least to clean, to separate some of the pollutant. So there are many different types of. So these people, these researchers are trying to enhance the efficiency of cleaning, filtering, come up with something cheap, widely available, and we can really separate all the pollutant or majority of the pollutant out of the water. So this particular project, they are exploring role of nanoparticles as a transporting agent for both pollutant and nutrients for the soil, water, and the air. So the idea is, if they apply or deploy those nanoparticles into the water stream or into the soil, into the water, they will latch onto the pollutant, or they will latch onto the nutrient, In case of pollutant, we have to, while they are less, we have to find a way to filter them out. In terms of nutrient, this will be the medium to distribute them into the water, into the soil or air, right? So this is basically, they are trying to understand transportation mode and how nanoparticle and those pollutant or nutrient will interact with each other, and they are trying to characterize those nanoparticles, how they can be utilized for pollution control, and also identifying the sources of this pollution. So yeah, and examples of the nanoparticle, these groups they are exploring is different types of iron oxide, clays, and other colloids like zeolites, porous soil conditioner, and silica gel, aluminosilicates. These are some of the materials they are exploring as potential nanoparticles to do whatever they are trying to do. So this is another project by NREL in Colorado, Denver. NREL, how many of you heard about NREL? So this is one of the US federal labs, one of the pioneer labs. Some of the best ideas and research came out from this lab. So United States has nearly 2,000 to 3,000 national labs. Ames National Lab in Iowa State University is where the nuclear fusion reaction was done first time. Fermi National Lab in western suburb of Chicago, that's where they did the testing of that neutron after they did the fusion test in Ames Lab in Iowa. And then you have Argonne National Lab in Chicago, another suburb of Chicago, also many of the basic scientific discoveries. And then you have Los Alamos Lab where all the maximum security research going on. And you have Oak Ridge National Lab, you have Brookhaven National Lab. And REL is also another pioneer national lab. They do renewable energy related research and also many other basic research, mostly in the field of energy and pollution control. So in this project, they are trying to develop a chemical agent of nanoscale to separate waste or remove waste from any medium, including water. So basically the whole idea is this will be the cleaning device. It will hold that chemical agent. Whatever water, air, or any other gaseous medium or micro medium you want to clean, you will send it through this cleaning device. The light will be exposed, and under the exposure of the light, this agent will react with the pollutant, specific pollutant, and it will separate it from the stream. Then you will get the clean air, clean water, or you want to clean a surface, right? So that's the whole idea of this particular project. And they found out that as the catalyst or the agent, one of the potential material they explored is titanium dioxide nanoparticle in the form of thin film inside that cleaning medium. So this is also a continuation of this project. They are also exploring fluorine, another form of carbon, as one of the potential agent to use as inside the cleaning medium. They are exploring molybdenum and sulfur also as part of the agent to basically clean wastewater. Single wall carbon nanotube also some people are exploring as a cleaning medium. Also single wall carbon nanotube is under research by NREL and some other research group as a hydrogen storage medium. Hydrogen storage, if fuel cell technology becomes a mainstream technology, we need to separate hydrogen and store hydrogen, because hydrogen separated from water is the fuel for fuel cell. So we need to store those hydrogen. That is one way. Or hydrogen can come as a contaminant in some air or some gas you are using. So carbon nanotube, single wall carbon nanotube is being explored as a potential filter for hydrogen for pollutant, or a storage mechanism for hydrogen that will be used in fuel cell. Now let's move to different, so far we talked about different types of filtering mechanism, cleaning mechanism, from water to, it can be fuel filter. If you want to purify your gasoline, because if you want to use it in aeroplane, you need a very highly purified gasoline. So right, even if you buy gas is 87, 89, 91, in some place you can buy 93, right? Price increases, what is it? It's just level of purification. Higher the number is higher the cost, because it's higher level of purification. So all this, everything we have discussed, all the research project, they are either talking about cleaning water, cleaning air, or cleaning any gaseous medium. It can be fuel or liquid fuel. Now, sensor technology, that is another important, has an application both for environmental application or biomedical application and many other applications. So one of the projects by Stanford University is they are trying to develop a sensor for hazardous gas. So most of us have at home a carbon monoxide detector, a smoke detector, right? One of the detector in my home was malfunctioning last 3 days. So I had to throw it, because these devices, it has gas sensors, right? To identify some of the harmful gas. Most common is the carbon monoxide. In the household, because we all have a water heater run by gas, we have a fireplace, sometimes we also have a central HVAC that is also run by gas. Whenever you are burning gas, then there is a chance of producing carbon monoxide. So, but in industrial environment, or the different types of modern gadgets we are using, some of those gadgets have different types of gas, and some of those gases are harmful. So, or it can react with something and produce harmful fumes. So, they are trying to basically come up with a sensor that will be useful for detecting any hazardous gas, particularly any leak. So the question is efficiency. They are trying to develop nanoscale sensors so that they can detect even atomic amount of poisonous gas. So that's basically they are trying to improve its efficiency. And based on their research, they're trying to develop some experimental sensor in partnership with some chemical lab. So in that project, they use actually this carbon structure as a sensor. So the idea is, everybody knows how electrochemical sensors. When there is a sensoring medium, when a certain ion or atom or particle you want to identify, when that particle is attached to that sensing medium, across its electrical potential changes, and if you connect this sensing medium with two conducting plate, externally you can measure the electric potential or the current change, and that change is the sensing mechanism. Change of current is the sensing mechanism. That is the electrochemical sensor. Basically, some chemical atom or ion or particle get attached to the sensing medium. As a result, across it, an electronic potential arises, or if there is already an applied voltage, the voltage will change, a current will change. That current is actually the way to detect it. In some sensor, it changes the light, like an optical sensor. The light changes its direction or intensity, and that is the sensing mechanism. That is optoelectronic sensors, right? So different types of sensors. So they are trying to develop an electrochemical sensors to detect smallest amount of poisonous gas into the environment, and the structure they are using as a sensing medium is a carbon nanotube. So they tested these experimental sensors to detect two forms of common poisonous gas. One is ammonia, the other one is nitrogen dioxide. Both are very poisonous gas. In the experimental carbon nanotube based sensors, they were able to detect up to 20 ppm, that is 20 parts per million. That is kind of this ppm is a indication of how accurate your detection mechanism is. So, in their project, experimentally what they observed, in addition to its size being at nanoscale, because it is based on carbon nanotube, it also, because it is based on carbon nanotube has a very high thermal stability, so it can operate at room temperature as well as at a very, very high temperature, because carbon nanotube has a thermal stability. Even if you heat it up at 500 degrees centigrade, it can still maintain its physical stability. Now the next topic I am going to explain the friendly energy. So when we talk about friendly energy, what we have to talk about? Energy that does not produce too much of byproduct or harmful byproduct or waste. So every time we are burning any gasoline product, we are producing carbon monoxide, in some time nitrogen dioxide, and some other harmful gas. Those are very detrimental to human health. If you inhale too much carbon monoxide, you can die in minutes. It happened to many times, particularly right after the snowfall. People forget that their car is parked outside, the tailpipe is clogged with frozen ice, and they try to start it. All the carbon monoxide comes back. Actually, if you just do Google search, you will find that every year several of this type of death is happening across northern hemisphere wherever there is a snowfall. Because if you leave your car outside 2-3 days, it's a general advice. After a snowfall, when you start the car, make sure that until the car is fully in operation, you leave one of the window open at least for 2-3 inches for the time of the car is starting. Wait for at least 30 seconds or less than a minute. Make sure that if there is any carbon dioxide backup, it goes out. About 7-8 years ago, I know one family in New York. One of their family member died. I know their friends and friends, so it's a close friend of my friend. So he actually sent me the picture. This gentleman came out to clean his car, and his wife was waiting on the porch with a cup of tea. So he went in, he cleaned the snow, he went inside the car and started. Carbon monoxide is a silent killer. You inhale it, you die without even throwing up your hand or anything. You die, it's a silent killer. So he thought that he was just taking rest after being tired of cleaning all the snow and cleaning the car. So he was like resting his hand on the steering wheel as if like he slept. After like 10 minutes, his wife got suspicious. And she went out, and then by the time he was already gone. So carbon monoxide poisoning from clogged tailpipe of car is one of the most common accidents. So be careful about it. So again, another thing is that solar energy has been talked about as alternative to fossil fuel. So solar energy is considered as one of the cleanest energy. However, it is not the cleanest energy because all the solar panel production and all the component production of the solar industry, it produces lots of waste by itself, right? So, no energy as of now is 100% clean. Nuclear energy is there. It is one of the most efficient energy production technique, but it doesn't pose immediate danger. But once an accident happens, it leaves an impact for next 100 years. Like that 3 Mile Island in Pennsylvania, one of the most famous nuclear accident in the United States, right? There was a movie. How many of you watched that movie? Erin Brockovich's movie. Julia Roberts starring that movie. She got, I think, Oscar, or she got nominated for Oscar. It was a leak from a nuclear plant. So downstream, it's based on a true story. Downstream, all the people up in the Appalachian Mountain or somewhere in the rural Pennsylvania, they're all getting skin disease. And many people were dying at early age. And after years of investigation, they found out that it is connected to that leak. So there was one of the biggest industrial lawsuit and damage given to that company. And then look at the Chernobyl. Still, babies are born deformed because of the impact of Chernobyl, and also the Bhopal accident in India. So the question is, so scientists, it's a dream to find a true friendly energy which will not produce any byproducts. There are some, like for example, hydroelectricity. All you need to put a turbine in the water flow, it will produce electricity. But the problem is, across the globe, there are very few rivers or water sources that is suitable to put a dam and produce hydroelectricity. And the problem is hydroelectricity has a limitation. It cannot produce enough energy to demand the supply of the energy, that level of energy we need. So what are the different technology people are exploring? Is there any more efficient way or less harmful way of converting solar energy into useful electricity? That is one. One possibility is improving the solar cell. Currently, any commercial solar cell, the maximum efficiency is 15%. Even if you can reach 30% efficiency in solar cell, it will revolutionize the industry. The other thing is the self-assembled nanostructure as a form of producing energy. High efficiency fuel cell are being explored, but it has not become a mainstream technology as of now. That needs efficient hydrogen storage medium. Nanoparticle reinforced polymer materials as the source of energy for automobiles. Actually, this is not source of, I misspoke. This is to make the weight of the car lighter, yet still keep it stronger like stainless steel. Lighter means it will consume less fuel. So now, earlier version of all cars, whether it's coming from Toyota or GM or Chrysler, used to have very strong steel body. 3 people could jump on it will not make a dent. But now, all the new cars, it's all carbon fiber. If you just sit on it, you will make a dent. So, now, because why? They are trying to reduce the gross weight of the car to increase the fuel efficiency. So there is indirect way of, and another revolution that silently took place in the last 10 years is changing the lighting technology, LED, right? 100 watts of conventional light now is consuming only 7 watts, right? That is another big revolution came. So now they're trying to improve, can we come up with better LED technology to improve the efficiency further. In the solar energy, what is the main problem with solar energy? Let's talk about efficiency. Why efficiency is so less? In the solar spectrum, it can be a hint for you. You are doing a power related project. In the solar spectrum, all the solar energy currently we have, it can only absorb the light in the visible range. And it can only absorb and convert only small portion of that visible range that has electron energy band gap equivalent to the base material silicon. So it cannot absorb any other light even within the visible range. So if we can have, MIT first introduced a tandem solar cell. A solar cell with 5 junctions instead of 1 junction. Each junction will have different material composition with different energy band gap. So it will consume different portion of the solar light spectrum. So larger portion of the solar light spectrum will be converted to electricity. That's called tandem solar cell or multi-junction solar cell. And people are now trying to do the commercial production of that. So why solar energy is still by far the most reliable and most potential friendly energy? Because it's abundant, it's free, and it is never ending. As long as the earth exists, we will have a sun to shine, right? So, whether you believe in doomsday or not, do not believe in, if you follow the natural progression or if you follow the guideline of our Holy Scripture, then one day the earth will cease to exist, or naturally another Big Bang will come, the universe will take a new form. Until that day, you and I, you don't expect to see that day, we will have a sun and it will be giving the raw material free. The problem with any other form of energy is the raw material is very expensive. Whether you are talking about clean coal technology or fossil fuel based thermal power plant technology or any other thing, you have to spend billions of dollars, invest hundreds of millions of man hours to collect those energy, raw material, convert it, refine it, convert it to useful form. In the process, you are making lots of waste, right? But solar energy is freely just radiating from up above. You have to just find a way to gather it and convert it to electricity. That's why solar energy is considered by far the most potential and ever-sustaining energy source. So that's why people are exploring quantum well solar cell, organic solar cell, dye-sensitized solar cell, carbon nanotube, or other carbon nanostructure-based heterojunction, multi-junction solar cell to be able to capture higher portion of solar sunlight. Quantum solar cell, again, it is all about increasing efficiency. If every single photon in the light spectrum can be captured, energy in the light is carried by photon, right? What do? We transfer that energy from the photon onto the electron in our conducting medium. That is a transfer of energy from light particle to electronic material particle. So if we can kind of interact with every photon, atom by photon, then efficiency will go up. And one of the potential ways they are saying that if we can come up with quantum well-based solar cell in the conventional solar panel, then we can actually improve the efficiency. And quantum well are very, very small in size. They are ultra-thin, nanoscale size. So, and they are based on narrow bandgap semiconductor. So it can you can deploy millions of them on a solar panel surface and absorb more sunlight. That's the goal. An organic solar cell based on nanocrystal. Organic solar cell did not get market. Solid state solar cell became more popular because originally organic solar cells efficiency even less than 10%. So now they're taking that with some nanotechnology integrated into organic solar cell, probably their efficiency could be increased. Self-assembled nanostructure. This is also another very, very important area of research, not only for energy, it is for many different applications. Let's say they're saying that if you have a defect on an aircraft engine, if the aircraft engine is made of materials that has the ability to self-assembly or self-correcting, then you can take care of those owned or some wreckage much more efficiently. So self-assembled nanostructure which can reform itself or take back its original shape or take a new shape with some force applied, that is a huge active area of research for electrical, mechanical, any field of engineering and science you can name. So one of the self-assembled nanostructure that is being explored is silicate-based nanostructure. This is they're trying to use some other technique. So this particular self-structured nanostructure, in this particular experiment, they tried to use it to purify iron ore. Or separate, if you have iron pollutant in the water, separate it. So, one of the example of that particular research group, and it is from Mobile, what they're trying to do with this particular self-assembled nanostructure. In this particular project, Mobile, of course, it's a oil company. So what they're trying to do, they're trying to come up with better purification, better refining technique. So in the fuel stream, there are lots of pollutant, including some harmful pollutant. That metallic ions or irons into the fuel stream. So if they're trying to basically come up with some self-assembled nanostructure of the size of 100 to 10 to 100 nanometer to actually attack those metal particles and capture them and separate them from the fuel stream so that they can have ultra-purified, ultra-refined oil. And they have a code name MCM41. I don't know what does it mean. Probably it's a way to hide the actual technology or actual composition of whatever material they are using. So, let's move to another sector. I'm trying to just introduce you different areas that people are exploring. For the fuel cell, so after solar cell, another important area of research people are spending a lot of money on. There is a company called Plug Power. There is another company called Ballard Power. There is another company called Fuel Cell. The company's name is Fuel Cell. So this is actually one of the pioneer. The Fuel Cell is a pioneer of fuel cell technology, and they are trying to use hydrogen as a fuel for running the engine. So Plug Power and Ballard Power, they signed an agreement with Walmart. All the lifting devices, the lift they have to bring down big pallet of products from the top of the shelf to the ground or put it up. So if you go to Home Depot, Walmart, any big store, you will see those forklifts. So many forklifts in Walmart now use hydrogen fuel cell based lifting engine, and Plug Power and Ballard Power is actually there supplying those to Walmart. So they have conventional forklift, also they are trying to promote these new types of forklift using fuel cell. So the main ingredients for fuel cell, the fuel itself is hydrogen. In gasoline based engine, it's the fossil fuel hydrocarbon, it's a hydrocarbon, right? All forms of gasoline or liquid gas or regular gas or gasoline is hydrocarbon. So the fuel component is hydrocarbon. We are burning hydrocarbon to generate thermal energy, and that thermal energy is converted to mechanical energy in engine, right? So one form or the other. So in fuel cell, it is the hydrogen is the fuel. So we need to have storage. So hydrogen storage, so that is one of the biggest challenge. First, separate hydrogen from water. That is one of the complex process. It's an expensive process. Still now it's not very efficient. And the second requirement is the hydrogen I separate. Hydrogen is a very reactive component. It doesn't stay by itself. So you have to store it efficiently in as pure form as possible. So hydrogen storage is another challenge. So people are now trying to come up with exploring different technologies, including carbon nanotube for hydrogen storage. And then we talked about nanoparticle reinforced polymer for automobile body to make it more lighter but more robust, more flexible, but it's reliable enough so that it can protect us from accident, from impact, right? So it has to have high tensile strength but low weight. So what is the direct benefit of lowering automobile weight, gross weight, by using nanoparticle? Direct weight is, if you think about the amount of gasoline we use for automobile across the globe, we are consuming about 1.5 billion liters of gasoline per year. So that equivalent of carbon dioxide will be reduced, and that equivalent is 5 billion kilogram of carbon dioxide will be reduced from the environment. So what can you do, each of us can do to absorb carbon dioxide from the environment?
Hold our breath.
You cannot hold that breath. I encourage you, spirit. Plant trees. If you have gardening habit, that actually not helps your mental health and physical health. It helps the planet. So, if you look at now let's move to the next one, the lighting technology. Why LED is a revolution? In United States, the total consumption of electricity, 20% goes to the lighting. From home to street to commercial venue to office, everywhere, it's 20% going to lighting. If we can change the lighting technology, so we are getting actually huge change of huge reduction in energy consumption, electricity consumption. When you consume less electricity, that means you are using less gas, you are burning less nuclear fuel. So overall, so if we can utilize nanotechnology based much more efficient LEDs and or other forms of lighting technology, it will reduce 10% of total energy consumption, and we are talking about hundreds of billions of dollars of savings per year. And it will reduce about 200 million tons of carbon emission per year. Next topic is waste-free industrial process. So in any industrial process, what we are doing? We are doing a bunch of raw material to convert them into useful products, or in food industry or in other consumer sector, raw material is being converted to useful product, whether it's edible product or non-edible product, right? This chair, tables, or whatever. But the problem with any conventional manufacturing process is not even 50% of the raw material is converted to the useful product. About 50% or more are byproducts we are throwing into the environment. Why? For several factors. One factor is the process efficiency. Even if you feed it with 100% pure raw material, still it cannot convert it to 100% product because of the process efficiency. The other thing is the raw material itself is not 100% pure. You want to feed oxygen, it is not 100% oxygen. You want to feed some minerals as a raw material, iron minerals, probably 80% will be iron, 20% will be other contaminant. So the raw material itself is not pure, or the process itself is not 100% efficient. Even if you feed 100% pure iron, it cannot convert it to useful product. There will be some system loss, right? So it is the dream for scientists and engineers. If we can convert 100% of raw materials into useful product, there will be no waste to worry about. Right? So, two ways you can do that. If you can come up with pure form of raw material, purifying it, that needs all the things we have discussed earlier, sensors, filters, to purify the material, make it 100% pure raw material. That the natural gas, the iron ore you are using, it has to be 100% pure. And then on the manufacturing side, the manufacturing process has to be 100% efficient. That if you feed it 10 grams of pure iron, it should convert it to products equivalents of 10 grams of iron. There should not be loss. So there are two. The other thing is that more practical and pragmatic way. More practical and pragmatic way is the raw materials will never be 100% pure. The process will never be 100% efficient. So what can we do?
Convert that waste into something useful.
Yes, very, very smart answer. Raw material, we'll try to make it as pure as possible. We make the manufacturing process as efficient as possible. The byproduct that we are creating, can we find a way to separate this into different groups of material, useful, non-useful, and make use of that byproduct as much as possible? So we'll have very minimum amount to throw into the water or landfill. So how can we use when waste from one process becomes feed for another process? Then that becomes its pure waste-free industry. In the utopian world, your raw material becomes 100% pure, your manufacturing process becomes 100% efficient, but that is an impossible goal to achieve. So more pragmatic goal would be to make smart filter, smart sensor to make those raw material as pure as possible, to improve the engine efficiency manufacturing as high as possible, but find a way to utilize the raw material as a feed for another thing. So we'll have less product or no product for dumping. So people are now exploring different ways to improve this manufacturing efficiency, as well as, and now let us introduce another sector, life-saving and healthcare technology. it is related to what we have discussed previously. When we are applying a medicine or taking any drug, prescription drug or over-the-counter drug, we are taking in a quantity more than we need. Why? Because the medium is swallowing or injecting, right? There are two ways we can basically take medicine. Inject it, swallow it, or spray it in our nose and ear or on the screen. There is no other way to take drug. Not even 20% of those ingredients will be actually ultimately take care of our disease. 80% will be waste. And because of the application method is not very efficient. Let's talk about cancer. One of the common treatment is applying chemotherapy. How chemotherapy is applied? You inject fluid along with the chemotherapy agent into the body, to the bloodstream, or you swallow the tablet and it goes through your body and it burns the cancerous cell. But while it is burning one cancerous cell, it also burns 100 healthy cells. That's why cancer patients, they lose their hair, they lose their skin, they become pale, they're weak. Why? Because chemotherapy agents burn also millions of healthy cells along with burning few hundred cancerous cells. So, because of the efficiency of application, efficiency of conversion, right? So, people are now exploring big nanomachine, nanotechnology-based machine, nanomaterial-based machine to improve the manufacturing efficiency and raw material purification. But at the inside the human body, at the micro level, they're looking for nanomachine that can travel through human blood vein, which will be of the size of human blood particle, like white blood cell, red blood cell. Of that size, it can travel through our circulatory system. It can track down the diseased cell, whether it's a cancerous cell or a deformed cell or a foreign virus, whether it's a COVID virus or some virus sitting, hiding in one corner of your body. It can track it down and apply the medicine on that virus or on that cancerous cell, pinpoint, localized, nanoscale application, so nothing will be burned. So I don't know, my wife complains that from COVID time and onward, I'm losing all my hair. I don't know whether there is a correlation, but somehow she found a theory that it has to do with me getting COVID 3 times. And all the medicine I have taken. It is her theory. So, anyway, people, they're trying to relate with, because within a given short amount of time, because of the nature of the pandemic, we have taken different types of medicine. Some are tested, some did not go through all the testing phases, right? Typically, any drug approval takes like minimum 5 to 10 years. It goes through several phases of trial and testing. But in this case, it didn't go all the phases because there was no time. So who knows? So the question is, this type of technology, along with gene sequencing, if we can use some nanoparticle or nanotechnology to actually come up with that type of nano-sized machine which can travel through human body and track down the damaged cell, cancerous cells or virus or bacteria, whichever is hiding, and apply the medicine, attack it and destroy it, nothing else will be destroyed. And genome research is another very, very important research, and that's where we can find many applications of nanomaterials, nanomachines, and nanotechnology in general. The whole idea is, what is the goal of gene sequencing, or any genetic research. One of the goals is precision medicine. What is precision medicine? I talked about one thing. The medicine we are swallowing or injecting into our body, not only 20% of it are being used to cure our disease. 80% are being filtered out, or it is just sitting idle somewhere in our body as a sediment, or it is filtered out through our urine or other forms of waste. But precision medicine is saying that I got COVID, you got COVID, you got COVID, you got COVID. All of us, I think, got COVID at least one time during the last COVID time, right? The consequence of each one of us of getting COVID is different. We felt different level of fatigue. Each one of us had different level of side reactions for the same disease. Sometimes it is due to our age. Sometimes this is due to our ethnic background because our genetic formation is different based on our ethnicity. Sometimes it is based on our eating habit. Same ethnic background, same age, same height, same weight. Our eating habit, our sleeping habit, our lifestyle can make one person more resistant to disease, one person less resistant to disease, right? So precision medicine is the idea that the cure which is applicable to you will not be applicable to you. Based on your disease and the level of the seriousness of the disease and your complete genetic code, and with all your background, including your age and ethnic and food information, they will come up with you a customized dose which will be only good for you. So they want to try to make the medicine least harmful, most effective, customized for each individual person at each individual situation. For the same disease, you may get affected differently at different conditions, depending on how your lifestyle in the last 7 days or last 3 years, right? So that is the precision medicine. University of Missouri Columbia campus that has started Precision Medicine Institute. Is a $200 million project, and nanomaterial and nanotechnology will be one of the important avenue to actually make that precision medicine successful. So to do that, we need to have a ability to basically make a complete genetic picture of each one of us. So
they need our genetic data.
well, all the big companies, they already have all of our data, whether you admit it or not. Like at home, I was looking for a lawnmower. The moment I logged into my computer at office, in my email I'm getting lawnmower ad, right? Over the course, they connected that computer in my home and this computer in my office. It's used by same person. They connected the dot. So I searched it at home in the morning. By the time I reached office half an hour, it's already there. So you see, they have all the information. So what is wrong with them having your genetic information? So
No, I'm just saying.
Unless your dad committed a crime 20 years ago.
No.
Okay.
So that's all for today. This is just, as I said, introduction of different areas that will be benefited or impacted by discoveries in nanotechnology world. So it's kind of something to think about your research project.
I have a last question.
Yes.
About the quiz. It's lecture 2 and 3.
Just first two topics I covered up until last week.
Yes.
Today, not today's topic.
Okay. The thing is, I was gonna ask.